Okay, here we want to look at a special application of the chain rule called the extended power rule. All right. So what we do, we use the power rule as we always have, but we always like to extend it by taking the derivative of what's in the parentheses. The good thing about the chain rule is it has many applications and it's very versatile. And remember, it's used primarily with what we call composite functions. All right. So first, let's look at this. We have the function f of x is equal to x cubed plus 4 to the 6th power. This is the classic application. Because if we didn't do it with the chain rule, of course, we would have to take this out, multiply it 6 times with each other, and then take the derivative. Okay, so we know that's very inefficient. Okay, so what we want to do, the derivative, we want to do like we've always used with the power rule. So we want to bring the 6 down. Okay, that's going to be x cubed plus 4, and the 6 turns into a 5. Okay, that's always been the case of what's happened. Remember, we multiply and we subtract 1. But the difference when we're doing the extended power rule, we take the derivative of what's inside the parentheses. What do we have inside the parentheses? X cubed plus 4. And the derivative here would be 3x squared. Okay, so that's the extension part. Remember, we brought the 6 to the front, kept our function, subtracted 1, all right? But then we had to multiply by the derivative of what was inside the parentheses. And the derivative of the parentheses in this case would be 3x squared. Okay, so let's finish this problem up. We multiply 6 times 3x squared will give us 18x squared. We're coming back with the exponents. That's going to be x cubed plus 4 to the 5th power. Let's come back with the exponents. And that's how we do this type of problem. This will be squared. This will be cubed. And this will be to the 5th power. Okay, in our next example, we have another application of the chain rule. But the difference now is we're applying it with the trigonometric function. So we have to remember what we did in our notes. So here, we're still going to do the product rule, which is first times the derivative of the second term plus the second term times the derivative of the first. But within this product rule, we will also be using the chain rule when we find the derivative of the second term, because that is not simply tangent x, that's tangent 3x. So be careful right here. So we have our first term, which is x to the 5th. Now, times the derivative of the second. So go back to the notes. We have 3 times secant squared 3x. I'm coming back with the exponents. Plus our second term, which is tangent 3x, times the derivative of the first, which is 5x to the 4th. Let's come back with the exponents. We know that was x to the 5th. All right. And so the key here, then that's going to be to the 4th. Now, we are not finished here. We want to write everything in the correct fashion. Okay. So this is going to be, after we bring our coefficient out, the 3x to the 5th times secant squared 3x plus 5x to the 4th times tangent 3x. Let me finish it and get everything back specifically how we want to write it. And we can take a long look at it and admire our work. So this is what we have. Once again, I'm going to go back through it. First times the derivative of the second term plus the second term times the derivative of our first term. First times derivative of the second plus second times the derivative of the first. Okay, now this last problem is one that we've looked over because it's an easy, very easy mistake to make. We have sine x to the sixth power. Note how this is written. As this is the same thing as sine x to the sixth. Now, the reason why I like to get people to rewrite it like this is because that way the definition goes hand in hand with the initial way that we learn how to do the extended power rule. It's the classic method. So let's look at this one. All right, we're going to have our derivative is going to be, let's bring that 6 down. I took it to the 6th power on purpose like we did the last one. And that's going to be raised to the 5th. And now the derivative of the parentheses, which is cosine x. All right, let's lift. Okay, this is what we have. And to finalize this, the way that we would probably see this written, of course, is different depending on the text that we use, but we would probably see this as 6 sine x to the 5th times cosine. So that's just a way that we could use the chain rule with the product rule, the classic chain rule, and the chain rule specifically with the trigonometric function. And when I say the chain rule, I'm referring to the specific case of the extended power rule. But this is very important to make sure we know our trig definitions and remain disciplined on our steps.